In question 1, we've got a curve C with equation y is 2 plus 10x to the half minus 2x to the 3 over 2. And in part A, we need to find dy dx, giving our answer in its simplest form. So we know that in differentiation, we multiply by the power and deduct 1 from the power. The derivative of 2 is 0. So we have that dy dx will be 10 times a half times x to the minus a half minus 2 times 3 over 2 times x to the half. This gives me 5x to the minus a half minus 3x to the half, which can be written as 5 over x to the half minus 3 root x, which can be further written as 5 over root x minus 3 root x. Please note that you would have scored full marks up to this line here. These are not necessary for you to get all 3 marks. In B, we need to find the exact value of the gradient of the tangent to see at the point where x is 2, giving our answer in its simplest form. So in other words, we need to evaluate dy dx, the expression we just got when x is 2. So we've got dy dx at x is 2. So we substitute x with 2, we get 5 over root 2 minus 3 root 2. I need to rationalize the first fraction here. So I will multiply top and bottom by root 2. So it's 5 over root 2 times root 2 over root 2 minus 3 root 2, leading to 5 root 2 over 2 minus 3 root 2. So this is simply minus a half root 2. In question 2, we've got these 3 points, P, Q, and R with the given coordinates. We need to prove that angle PQR is 90 degrees. Now, there are many ways you can approach this. Perhaps the easiest way is to consider gradients. So if angle Q is a right angle, that means that the gradient of PQ and the gradient of QR should be multiplying out to -1 to prove that they are perpendicular and therefore the angle is 90 degrees. So let's just do this. We've got the gradient of PQ. I'm doing y2 minus y1 over x2 minus x1. So it's 11 minus 7 over 9 minus -3. This gives an answer of a third. And I will now do the gradient of QR. So for the gradient of QR, it's again rise over run. So 2 minus 11 over 12 minus 9, which gives an answer of -3. We notice that the gradient of PQ times the gradient of QR gives a result of -1. And therefore we conclude that the two lines are perpendicular and therefore PQR is 90 degrees as required. It is imperative that you show that the two gradients multiply out to -1 to get the final mark. In part B, we are told that there's a point S such that PQRS forms a rectangle and we need to find the coordinates of S. I will start by drawing a rectangle, putting all the information we've got up to now. It's points P, Q, and R, and the point down at the bottom is point S. So we need to find the coordinates of S, and the idea is that the route from R to S is the same as the route from Q to P. So we have the coordinates of Q and P, and we see that to go from Q to P, I need to go 12 units to the left. So from 9 to -3, that's 12 units to the left, followed by 4 units down from 11 to 7. So I'll do exactly the same from R to S. I'll go 12 to the left and then 4 down. So that means that if S has coordinates x, y, then x is simply 12 minus 12. So that means that x is equal to 0. And for y, I go from 2, 4 down, so I go to -2, and therefore y is -2. So we conclude that point S has coordinates 0, -2. In question 3, we're being given this integral, and we need to give our answer in its simplest form. So we've got the integral of 4x to the 5 plus 3 over 2x squared. I will start by splitting this into the integral of 4x to the 5 over 2x squared plus 3 over 2x squared dx. I will write this in index form, which means it gives me the integral of 2x cubed plus 3 over 2 x to the negative 2 dx. We know that in integration we increase the power by 1 and we divide by the new power. So 2x cubed will give me 2x to the 4 over 4 plus 3 over 2, and then x to the negative 2 will give me x to the negative 1 over negative 1, and that is a plus c, the constant of integration. Now the 2 with the 4 simplify out to give me a 2 in the denominator. So this leads to a half x to the power of 4 minus 3 over 2 x to the negative 1 plus c. That's my simplified answer for question 3. In question 4, we're given this quadratic kx squared plus 6kx plus 5 is 0. K is a non-zero constant, and we're told that it has no real roots, and we need to find the range of possible values for k. Now we know that no real roots simply means that the discriminant of the given quadratic should be negative. So in our case, a is k, b is 6k, and c is 5. The discriminant is b squared minus 4ac, and this is what we want to be less than 0. So we get 6k all squared minus 4 times k times 5 is less than 0, leading to 36k squared minus 20k being less than 0. We see that there's a common factor of 4k, so 4k brackets 9k minus 5 is less than 0, and we can find the critical values for this quadratic inequality. So the critical values are the values of k that make the left hand side 0. So we've got that k is 0, or 9k minus 5 is 0, leading to 9k is 5, and therefore k is 5 over 9. So we've got the two critical values, which I will put on a quadratic. It's a smiley face because the coefficient of k squared is positive. So we've got the critical value at 0 and 5 over 9. We can see that it goes plus, minus, plus. We want to be less than 0, so we want to be in the middle. So we take the inside region and we conclude that 0 is less than k, which is less than 5 over 9. In question 5, we need to show all stages of the working, and solutions relying on calculator technology are not acceptable. This simply means that you need to show every single step along the way to justify all the marks. So we need to use a substitution that p is 3 to the x to show that the given equation here can be written as a quadratic in p. So let's start with what we're being given is 3 times 9 to the x plus 3 to the x plus 2 is 1 plus 3 to the x minus 1. I notice that 9 is 3 squared. So we've got that 3 times 3 squared to the x plus 3 to the x times 3 squared, because when you've got addition of powers, it's multiplication with a common base, is equal to 1 plus 3 to the x over 3 to the 1, because when you've got subtraction of powers, it means you had division with the same base. So 3 squared to the x can be written as 3 to the x squared. So 3 times 3 to the x squared plus 3 to the x times 9 is equal to 1 plus 3 to the x over 3. We're going to use the suggestion of the substitution of p is 3 to the x. So let p is 3 to the x, which leads to 3p squared plus 9p is 1 plus p over 3. I will multiply throughout by 3 to get rid of the denominator of 3. So 9p squared plus 27p is 3 plus p. And I will collect everything on the left hand side to give me 9p squared plus 26p minus 3 is 0 as required. In part B, we are asked to solve the given equation based on the work we did up to now. So I will actually consider the quadratic in P. This factorizes into 9p minus 1, the first bracket, p plus 3, the second bracket. So we know that either 9p minus 1 is 0 or p plus 3 is 0. So we get 9p is 1, which means that p is 1 over 9. We know that p was 3 to the x, so we have that 3 to the x is 1 over 9. Well, obviously 9 is 3 squared, So 1 over 3 squared is 3 to the negative 2. And since we've got the same base, I can equate the powers, and I see that x is negative 2. Moving on to p plus 3 is equal to 0. We have that p is equal to negative 3, which means that 3 to the x is negative 3. Now this is rejected. It's not valid, simply because if I raise 3 to any power, then I can never get a negative result. So since 3 to the x is greater than 0 for all x. Question 6 is giving us the plan view for the design of a stage. We've got a sector OBC, it's the one here, and we've got two congruent triangles, OAB and ODC. We are told that angle BOC is 2.4 radians, so let me annotate my diagram. This is 2.4. The area of the sector BOC, this one here, is 40 square meters, and the AOD, this line here, is 12.5 meters in length. We need to find the radius of the sector in part A, giving our answer in meters to 2 dps. Well, we know that since the question is phrased in radians, the area of a sector when the angle is in radians is simply a half r squared theta. So in our case, we've got the area is 40. We are looking for the radius, so a half r squared, and the angle is 2.4. So this leads to 40 is 1.2 r squared. So 40 over 1.2 is equal to r squared. I'll simply take the square root of the left hand side, so the square root of 40 over 1.2 will give me r, which turns out to be 5.77 meters, correct to 2 decimal places. In part B, we need to find the size of the angle AOB in radians to 2 decimal places. Well, AOB is here, and we know that this angle and this angle are equal because the two triangles are congruent. We know that all of this is pi radians, so I will simply do pi minus 2.4 and divide this by 2. So the angle AOB is pi minus 2.4 over 2, and this gives an answer of 0.37 radians. In part C, we need to find the total area of the stage, giving our answer in square meters to 1 dp. So we've got the area of the sector and the area of the two congruent triangles. We have already been given that the area of the sector is 40 square meters. We have found that angle BOA is 0.37. We have already found that the radius is 5.77 meters. And we have been given that AD is 12.5 meters, which means that AO is 6.25 meters. So the idea is simply to find the area of triangle BAO, double it because OCD is a congruent triangle, and then add the 40. So to find the area, I'll be doing 2 times the area of the triangle, which is a half AB sine C, a half times 6.25 times 5.77 times sine of 0.37. Remember to put your calculator in radian mode because 0.37 is radians, and then add the 40. I'm using full accuracy, that's why I'm writing the 3 dots here. I'm not restricting myself to the 2 dps, I'm using full accuracy. This gives an answer of 53.075 ... which to 1 decimal place is 53.1 square meters. In part D, we need to find the total perimeter of the stage, giving our answer in meters to 1 dp. So we need to find the AB part here and double it because CD is exactly the same. We need to find the length of the arc here and then add the 12.5, which is the total distance AD. Let's start by finding AB. I'll be using the cosine rule here. So we have that AB squared will be equal to 6.25 squared plus 5.77 ... squared minus 2 times 6.25 5.77 ... cos of 0.37 ... This leads to 5.77 2.1317 dot dot dot. I'll take the square root to find AB, and this gives an answer of 2.2653. We also know that the length of an arc when the angle is measured in radians is given by r theta. So the perimeter will be found by doing 2 times the 2.2653 plus the 12.5, which is the total distance from A to D, plus the length of the arc, which is r times theta, which is 2.4, and this gives 30.887 dot dot dot, which to one decimal place is 30.9 meters. In 7a, we need to sketch the graph of y 6 over x, and x cannot be 0 because obviously when x is 0, then we're dividing by 0, which leads to an undefined result. We know that this curve here belongs to the reciprocal family, and because the numerator is positive, then we are in the first and the third quadrants, so it should look something like this. That's the graph of 6 over x. In part B, we're told that C is transformed to the curve with the equation y is 6 over x minus 2, and we need to fully describe this transformation. Well, I will actually start by defining f of x to be 6 over x, and we're now considering y to be 6 over x minus 2, which can easily be seen to be f of x minus 2. Well, this is a translation 2 units to the right, because we've got x minus 2 in the brackets. We know that whatever goes in the bracket goes along the direction of x, contrary to what you would expect. So as you see it, you are tempted to deduct 2 from x, but you actually do the opposite. You add 2 to x, so you are actually translating 2 units to the right. We are then told that the curve with equation y is 6 over x minus 2 and the line with equation y is kx plus 7 intersect at exactly 2 points P and Q. Additionally, we are told that the x-coordinate of P is -4, and we need to find the value of k and then proceed to find the coordinates of point Q. Well, let's start by stating that at Px is -4, and we will substitute the -4 into the reciprocal graph here, 6 over x minus 2, to get the y coordinate. So y is going to be 6 over -4, -2, which gives an answer of -1, and we can proceed in that to find the value of k. We have that y is -1 to be substituted into the straight line equation, so -1 is k times -4 plus 7, so -1 is -4k plus 7, leading to 4k is 8, and therefore k is equal to 2. And we now proceed in using algebra to find the coordinates of point Q, the other point of intersection. So where do we stand at the moment? We've got two graphs. We've got y is 6 over x minus 2, and we've got y is 2x plus 7 because we found k to be 2. I will equate the two since I'm looking for the point of intersection. So 6 over x minus 2 is 2x plus 7. I will cross multiply, so 6 is 2x plus 7 times x minus 2. I will expand this to get 2x squared minus 4x plus 7x minus 14, which leads to 0 is 2x squared plus 3x minus 20. I will factorize this into x plus 4, 2x minus 5. So we get that either x plus 4 is 0 or 2x minus 5 is 0. Well, I'm not surprised that we had x plus 4 is 0 because it leads to x minus 4, and this is exactly the x coordinate of point P. But we've got 2x is 5 on the right hand side, leading to x is 5 over 2. So this is the x coordinate of point Q. I will substitute x is 5 over 2 into the straight line to get the y coordinate of point Q. So we have that y is 2 times 5 over 2 plus 7, which gives an answer of 12, and therefore Q has coordinates 5 over 2, 12. In 8, we've got a sketch of the straight line L and the curve C. Now for the line L, we know that it cuts the x-axis at 4, 0, and it cuts the y-axis at 0, negative 12. And we're being asked to find an equation for L in the form y cos mx plus c. So let's start by stating that for line L, we know that we pass through 4, 0, and 0, negative 12, which means that I can find the gradient by doing y2 minus y1 over x2 minus x1. So it's minus 12 minus 0 over 0 minus 4, which gives an answer of 3. We notice that the y-intercept c is simply the negative 12, and therefore we conclude that the straight line L has equation y is 3x minus 12. We are then told that curve C has equation y is f of x, where f of x is a quadratic expression. It has a minimum point at 7 minus 18 as shown on the graph, and cuts the x-axis at 4 and at k. So the second cut here is k, and we're being asked to deduce the value of k for a mark. Well, the prompt to deduce means it's something that does not require extensive working, and I will actually base my conclusion on observing that if the minimum point is at x is 7, then by symmetry the distance between 4 and 7, which is 3, should be the distance between 7 and k, so also 3. So from the minimum, I go 3 units to the left and I find 4, and I go 3 units to the right and I find k. So this means that k must be 10. We are then told to find f of x. So one way I could approach this is based on the fact that the minimum point is 7, negative 18. So I will make an educated guess on the form of f of x. I know it's a quadratic expression, so for it to have a minimum at 7 minus 18, it means that it can be written in the form of x minus 7 squared minus 18. And there is a chance that there is a constant here. I'll call it alpha, which I'm trying to find. So why does this form work? Well, when x is 7, then the whole bracket here drops dead and it's minus 18. And because something squared will always be greater than or equal to 0, I know that the graph of f of x will be from minus 18 upwards. So the minimum point will be at 7 minus 18. In other words, this particular form is forcing this quadratic to have a turning point, a minimum or a maximum at 7, negative 18. Now I'm going to use the fact that we pass through 4, 0. So f of 4 is equal to 0, which means that 0 is alpha times 4 minus 7 squared minus 18. So I get that 0 is 9 alpha minus 18. So 18 is 9 alpha. So alpha is 2. And we get that f of x is equal to 2 times x minus 7 squared minus 18. Now, was there an alternative way of doing this? Of course, there's an alternative way. So alternatively, you could have said that if we cut the x-axis at 4 and 10, it means that this quadratic factorizes with factors being x minus 4 and x minus 10. So I could say that f of x must look something like alpha times x minus 4 times x minus 10. So this particular form is forcing f of x to be 0 when x is 4 and when x is 10. So I'm actually forcing the two cuts on the x-axis to be exactly where we want them to be, at 4 and 10. But there is a chance that there is a constant outside, so I need to determine the value of this constant. I will be using the minimum point, the 7, negative 18. So I will be saying that f of 7 is negative 18, which means that minus 18 is alpha times 7 minus 4 times 7 minus 10, leading to minus 18 is minus 9 alpha, and therefore 2 is equal to alpha, leading to f of x is 2 brackets x minus 4 brackets x minus 10. The two expressions we obtain, this one and this one, are exactly the same if you expand them. In part D, we need to use inequalities to define the region R. So the region R is the region shaded here. Obviously, I want to be above the straight line and I want to be below the parabola. So above the straight lines means that y is greater than or equal to 3x minus 12. Below the parabola means that y is less than or equal to 2 brackets x minus 7 squared minus 18, or the other form shown here. And we also need to be on the right hand side of the y-axis, but certainly before x is 4, so we need to restrict x to lie in the corridor between 0 and 4. So I also need to state that 0 is less than or equal to x, which is less than or equal to 4, to complete the full set of inequalities that define the region R. In question 9, we've got a sketch of the curve with equation y is tan x and the straight line L here with equation y is pi x in the interval minus pi to pi. We need to state the period of tan x. Well, before stating the period of tan x, let me add the asymptotes at pi over 2 and the negative pi over 2 that the tan graph has. We know that it cuts the x-axis at pi, at 0, and at negative pi. When we speak about the period, we mean the range of values of x in the horizontal for us to see the full nature of the wave. So we can see that the period of tan is pi, because from minus pi over 2 to pi over 2, I see the full wave, and then it's a repetition of the same wave over and over again to the left and to the right. So the period of tan x will simply be pi. In part B, we need to write down the number of roots of the equation tan x is pi plus 2x in the interval from minus pi to pi. So remember that the straight line L here has equation y is pi x. So the straight line y is pi plus 2x will be steeper than this one. So it will probably look something like this. Y is pi plus 2x. We are looking for the number of roots, so the points of intersection between minus pi and pi. And we see that there is one here, it's the origin, and then another here. So between minus pi and pi, we've got exactly 3 roots. So in BI, my answer is 3. We are then told to find the number of roots for tan x is pi x in the interval from minus 2 pi to 2 pi. So we see that in the region from 0 to pi, we've got one root here. So when we go another pi to the right, there will be another solution somewhere over here. So 2 solutions from 0 to 2 pi. Similarly, there will be 2 solutions from 0 to negative 2 pi, and we also have the origin as well. So in total, there will be 2 plus 2 plus 1, which is 5 solutions in total. And then we have tan x is pi x in the interval from minus 100 pi to 100 pi. I will use exactly the same logic as we did in II. Because in II, we said that from 0 to 2 pi, we had 2 solutions. So in a span of 2 pi radians, we get 2 solutions. So in a span of 100 pi radians, we'll get 50 times that. And another 50 times 2 solutions from negative 100 pi up to 0. So 50 times 2 is the number of solutions from 0 to 100 pi. 50 times 2 is the number of solutions from minus 100 pi up to 0, and you've got that extra solution at the origin exactly, leading to 201 solutions in total. In question 10, we're being given a sketch of part of the curve C with the equation shown here, and we need to state the values of x for which f of x is greater than 0, so the values of x for which f of x is above the x-axis. So we can see it's the part over here and also the hump over here. So in order to find the values of x for which f of x is greater than 0, I will actually start by solving f of x is 0. Luckily enough, we've been given the f of x in a factorized form, so that means that 3x plus 20 is 0, or x plus 6 is 0, or 2x minus 3 is 0. So we have that 3x is negative 20, so x is minus 20 over 3, or x is negative 6, or 2x is 3, which means that x is 3 over 2. So that gives me the cuts on the x-axis. So the cut on the positive x-axis is 3 over 2, and on the negative x-axis it's minus 20 over 3 and negative 6. So we see that f of x is greater than 0 if x is between minus 20 over 3 and negative 6. So minus 20 over 3 less than x less than negative 6, or when x is greater than 3 over 2. In part B, we need to expand 3x plus 20, x plus 6, 2x minus 3 to give our answer as a polynomial in its simplest form. So I could leave the 3x plus 20, expand the last two brackets, and then do the full expansion. So x times 2x is 2x squared minus 3x plus 12x minus 18. I will collect the like terms in the second bracket, leading to 2x squared plus 9x minus 18. And I'll do a further expansion to get 6x cubed plus 27x squared minus 54x plus 40x squared plus 180x minus 360, which leads to 6x cubed plus 67x squared plus 126x minus 360. That's the expanded polynomial in its simplest form. We're then told that the straight line L is a tangent to C at the point where C cuts the y-axis, and given that L cuts C at the point P, we need to find, using algebra, the x-coordinate of P. So I will start by finding where the f of x is cutting the y-axis, this part here. So we have that f of x is 6x cubed plus 67x squared plus 126x minus 360. A cut on the y-axis means that x is 0. So it's easy to see that y will be minus 360, and therefore the point at which we cut the y-axis is 0, negative 360. Now, because L is a tangent to C, I will find the derivative f dash of x. So f dash of x, remember we multiply by the power and we deduct 1 from the power. So it's 6 times 3x squared plus 67 times 2x plus 126, simplifying to 18x squared plus 134x plus 126. I will evaluate the gradient function when x is 0, because that's the point at which the line is a tangent to C. So f dash of 0 is simply 126. So we know that the straight line L is having a gradient of 126 and the y-intercept of minus 360. If I would quickly go back to my graph here, we have found through the gradient that m is 126 by doing differentiation and all of that, and we know that we cut the y-axis at minus 360. So the straight line L has equation y is 126x minus 360, and in order for us to find the point of intersection between the straight line and the curve, again I simply equate the curve with the straight line. We get 126x minus 360 is equal to 6x cubed plus 67x squared plus 126x minus 360. Lucky us, the minus 360 cancels out, and so does the 126x. We notice that we've got a common factor of x squared, and we've got x squared brackets 6x plus 67. So we have that either x is 0 or 6x plus 67 is equal to 0, leading to 6x is negative 67. So x is minus 67 over 6, and therefore we conclude that hence at P the x coordinate is minus 67 over 6. In question 11, we've got the curve y is f of x. We've got the second derivative of f of x. We are being told that the point P has x coordinate 4 and lies on C, and the tangent to C at P has equation y is 3x plus 4, and we need to find an equation of the normal to C at P. Well, we know that the point P lies on the curve but also on the tangent, so it must satisfy this equation here. So I will start by saying that when x is 4, we have that y is 3 times 4 plus 4, which gives an answer of 16, and therefore point P has coordinates 4, 16. So the gradient of the tangent, I can simply read this off from the gradient of the straight line, it's 3. So I can conclude that the gradient of the normal is minus a third. Remember, we flip and we change the sign. So using y minus y1 is mx minus x1, I can write down an equation for the normal. So y minus 16 is minus a third brackets x minus 4. I do not need to put this in a particular form, so I can leave it like this and claim full marks. Now in part B, we need to find the f of x, writing our answer in its simplest form. Notice that this is 6 marks, so it involves quite some extensive working. I will start by finding f dash of x based on the fact that we've got the second derivative. I will integrate once to find the first derivative. So f dash of x should be the integral of 4x plus 1 over root x dx. I will write this in index form, so it's the integral of 4x plus x to the minus a half dx. So remember, in integration, we're increasing the power by 1, dividing by the new power. So this will lead to 4x squared over 2 plus x to the half over a half plus c. So we have that f dash of x is equal to 2x squared plus 2x to the half plus c. We know that the gradient of the curve when x is 4 is 3. This is coming from the point P. So f dash of 4 is equal to 3, which means that 3 is 2 times 4 squared plus 2 times 4 to the half plus c, which leads to 3 is 32 plus 4 plus c. So we get that minus 33 is equal to c. And we've got the full expression for f dash of x, which is 2x squared plus 2x to the half minus 33. And of course, now we'll proceed again with integration to go from f dash of x to f of x. So f of x will be the integral of 2x squared plus 2x to the half minus 33 dx. So this will give me 2x cubed over 3 plus 2x to the 3 over 2 over 3 over 2 minus 33x plus yet another constant of integration. This simplifies to f of x being 2x cubed over 3 plus 4x to the 3 over 2 over 3 minus 33x plus c. And we know that the point P had coordinates 4, 16, which means that f of 4 is 16, and therefore 16 should be 2 times 4 cubed over 3 plus 4 times 4 to the 3 over 2 over 3 minus 33 times 4 plus c. This leads to 16 is equal to minus 236 over 3 plus c. and therefore my constant of integration is 284 over 3. So I can proceed in stating that f of x should be 2x cubed over 3 plus 4x to the 3 over 2 over 3 minus 33x plus 284 over 3, and that will be the final answer.